We are beginning Unit 8, which is all about trigonometry. You have done some trigonometry in your past in geometry, so some of this might be a refresher, and then maybe there'll be some new things as well as we tackle this in Algebra 2. The first little bit of our problem set today is just kind of getting you used to some of the symbols and words and vocab that we're going to be using throughout this unit. So let's just kind of take a look at the picture I have here and what I've said in number 1. Trigonometry is the study of triangles. So a lot of times we are dealing with triangles in these problems, specifically right now, right triangles. And with any right triangle, we have a special formula, the Pythagorean theorem, that we know we can use at any point to deal with the side relationships. So we know that the two legs of the triangle, so that's our A and our B are the legs. If we square those and add them together, then it's equal to the hypotenuse squared. So another key word there was hypotenuse. That's always the side opposite your right angle. That will always be your hypotenuse. Now, a lot of times when we deal with trig and angles in triangles, we use Greek letters like theta. Here's a theta, or alpha. All right, so you're going to see some Greek letters used to represent angle measurements. We usually also use lowercase letters to represent side lengths and uppercase letters to represent angle measurements. So you can see that in the picture as well with the ABC and the lowercase ABC. Another geometry connection, you should remember that when we label sides, they're always opposite the angle measurement. What I mean by that, notice here we have angle A, and opposite of angle A is side A. All right, then the last piece I want to just talk about here is, we talked about hypotenuse already, but this opposite side and adjacent side. Now, it all depends what angle you're looking at and referring to when you label the opposite side and the adjacent side. The way I have it labeled for this particular triangle is as if I'm starting from theta. If you start from theta, the opposite side of theta would be side B. So that's why I have that called the opposite side. The adjacent side, which basically means right next to. Now you might be thinking, well, wait, there's two side lengths that are right next to theta. Well, one is the hypotenuse, so we aren't going to also call that adjacent. The hypotenuse is the hypotenuse, and then our adjacent side would be the other side length or the other leg of the triangle. All right, so that was a lot of words, but just wanted to make sure you have some of those key terminology pieces down. Now, what you might remember from geometry is that when we started this study of triangles, we brought in some functions. They're called our trig functions, and you mainly focused on sine, cosine, and tangent trig functions when you were in geometry. So I'm going to just remind you of a little memory device that you may have had for these trig functions and what they represent in your triangle, and that is the memory device SOHCAHTOA. So I'm going to write that out here. So SO is S-O-H, CA is C-A-H, and TOA is T-O-A. So whenever you're talking about sine, you're talking about sine of some angle. So notice here I have sine of theta, theta just being our generic angle. And the SO helps us know that sine of theta is always equal to the opposite side over the hypotenuse in a right triangle. Likewise, the cosine of some angle is always equal to the adjacent side length over the hypotenuse of a right triangle. And then the tangent of theta is always equal to the opposite side over the adjacent side. So those are our three main trig functions and how they use the sides of a triangle to represent a ratio. Now, the next three trig functions might be new to you. Maybe you've heard of it, maybe you haven't. But we have a cosecant trig function. and that is abbreviated CSC. It's the cosecant of theta. And then we also have a secant, abbreviated as SEC, of theta. And then we have a cotangent, which is COT of theta. Now, if you look over here, I have those trig functions with their ratios written out. And what you may notice is these ratios are very similar to the ratios we saw with sine, cosine, and tangent of theta, but they're flipped. So what I want you to really note here is that sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals of each other. And tangent and cotangent are reciprocals of each other. So down here, when I ask you what cosecant is in terms of 1 over something, it's 1 over the sine of your theta. Secant is 1 over the cosine of your theta. And cotangent is 1 over tangent of theta. They're just reciprocals of those 3 original functions that you already know. I don't know that you necessarily need to memorize the hypotenuse over opposite, hypotenuse over adjacent, etc. I think if you know sine and then you have to do cosecant, you really just need to flip that fraction. So that's an easy way to think about these problems. So let's actually do some examples together so you see the types of problems that you're going to be asked to do. So I have given you a right triangle here. I've labeled 2 of the side lengths, and I'm asking you to give me the ratios for all 6 trig functions. So that means we want to come up with the opposite over hypotenuse for the sine, the adjacent over the hypotenuse for the cosine, and the opposite over the adjacent for the tangent. Now we're going from our theta angle, so theta is labeled up here, so we're going to start here and figure out where the opposite, adjacent, and hypotenuse are. Well, we always know the hypotenuse is opposite the 90, so we could label that right away. Opposite, if I just start at my angle and go directly opposite, I know this will be my opposite side of theta, and then right next to is my adjacent side. So I can label those side lengths. Some people write them down, some people just realize from looking at them what they are. Now we are going to need to write the hypotenuse, but we don't have its value. What's nice is we already know 2 sides of a right triangle, therefore the third can be found using Pythagorean theorem. So 3 squared plus 4 squared has to equal, we usually call our hypotenuse the c side, so we'll just say equals c squared. So we have 9 plus 16, so 25 equals c squared. This must be 5. Some of you might have realized it was a 3, 4, 5 special right triangle. So now we have enough information to answer this question. The sine of theta is 4 over 5. I just took the opposite side over the hypotenuse. The adjacent is 3 and the hypotenuse is 5, so the cosine of theta is 3/5. The tangent of theta, the tangent is opposite over adjacent, so that would be 4/3. So these would be our ratio answers for the 3 main trig functions. We can now very easily do their reciprocals. So we have 5/4, 5/3, and 3/4. All right, so that is one type of problem that you should be able to handle. All right, moving on. In this next section, I am going to give you some pieces of information about a right triangle. You are welcome to use the picture that I have over here if you want, or you can draw your own. And then you are going to find a specific piece of information. So in this first problem, we're going to be finding side C. I know it's a side because it's the lowercase. So I can fill in that my angle B, and I'm going to just do it right here. Whoops. So here's my side C. I had B labeled here in my picture, so that's fine. I'm going to call that 26 degrees. Now side B would have to be opposite angle B, so my 10 must be here. So here's labeling just what I know and what I'm trying to find. What you want to do in a problem like this is you want to set up a trig equation that you can solve. So I'm going to look at my angle that I know, which is 26, and I'm going to decide how I can use the 10 and the C in an equation. Would it be with a sine equation? Would it be with a cosine equation? Or would it be with a tangent equation? Because 10 is opposite the angle 26 and C is the hypotenuse, I know that sine uses the values of the opposite and the hypotenuse in it. So I'm going to say the sine of my theta, which is 26, is equal to 10 over C. So this is the equation I need to solve. Now I am going to use my calculator to do this. So I'm going to move over to my calculator on my iPad. You might want to get your graphing calculator out. One thing you want to do whenever you're dealing with trig is you always want to check your mode. So I'm going to hit the mode button here. Now my mode screen looks different than yours does on your graphing calculator because I'm just using a slightly different app here. But about 3 options down, you should see the choice between radian and degree in your guys' calculator. Because our triangles are dealing with angles that are degrees, we want to be in degree mode right now. So make sure you make that change so that you're all in degree mode. And other than that, you should be good to go. Again, the only time that mode is mattering for us is when we are dealing with trig. We're about to do a sine, cosine, tangent. That is when we have to make sure we're in the right mode. All right, so let me go back to my screen and see what exactly I want to put into my calculator to solve this problem. I would like to find C. Now, C is in the denominator, so we're going to have to use some of our math and algebra skills here. I'm going to move C to the other side so that it's not in the denominator anymore. So C times the sine of 26 is equal to 10. Now to get C alone, I'm going to divide by the sine of 26. So the math I want to enter into my calculator to solve for C is 10 over the sine of 26. All right, and so there's your calculator entry, and you can see I get 22, and we'll just round to the tenths here, 22.8. You can go to the hundredths if you want, 22.81 for that side length. All right, so now we're going to go ahead and set up the next scenario. And for this problem, I've given you angle A this time. So notice our angle A is up at the top. You really can label it wherever you want as long as you're consistent with where you label the different side lengths. Side B, so I usually know my hypotenuse is called side C. So side B will be here because side A has to be directly opposite. And I knew that side B was equal to 6. So what I'm going to do to decide what trig function to use to help me solve for A, I'm looking at my angle I know, and then I'm comparing it to the side B, which I know is 6, and then I also need to incorporate A because that's what I'm trying to find. The C is kind of irrelevant for this problem. So A and B are the opposite and the adjacent sides to my angle 42. Therefore, I would want to set up a tangent equation. And I know that the tangent of my angle, 42 degrees, is opposite, which is A, over adjacent, which is 6. Now this problem maybe looks a little bit easier to get A alone. I just have to multiply the 6 to the other side. So in my calculator, I'm going to do 6 times the tangent of 42. And I get 5.4 for my side length A. And again, that's what I was solving for in this particular problem. All right, so the next situation we have, I've given you angle B, and this time I've given you side C, which again we said was the hypotenuse, Angle B was down here. That's our 12 degrees. We're going to find side A. So I know side B is opposite angle B, so side A must be this other side length. So I am trying to figure out a trig function that relates my angle 12 with A and C, which was the 23. So A was adjacent to 12. C is the hypotenuse. So adjacent and hypotenuse is a cosine relationship. The cosine of my angle is equal to the adjacent over the hypotenuse. Again, I'm just using all my SOHCAHTOAs right now to set these up. And then my solving for A will simply be to multiply both sides by 23. So in my calculator, I can do 23 times the cosine of 12. And I get 22.5 if I round. And that was side A. All right, our next problem, we are given side A, side C, and we're trying to solve for angle B. So we haven't solved for an angle yet. So we're going to call our unknown angle B. I'm just going to call it theta. And our side B, we remember, is opposite it. Side C is the hypotenuse, so side A must be over here. So this time the equation that I'm going to set up, I'm still looking at where my theta is, and I have to relate the side length of 4 and the side length of 15 to that angle. So 15 we know is hypotenuse, 4 is adjacent. This would be a cosine relationship because adjacent and hypotenuse are my cosine, but this time I don't know the angle. So cosine of theta is equal to 4 over 15. And if I need to find this theta, because again, this theta is my angle B, I need to know how to solve this equation. I need to essentially separate the cosine and the theta. And no, you cannot just divide by cosine because cosine has to be with an angle. It wouldn't make sense to just type cosine into your calculator with nothing with it. But what we can do is we can separate cosine and theta by using our inverse operations. We use inverses to move things around in math. So I'm going to use the inverse cosine. Remember that symbol for inverse is that -1 in that exponent. And we're going to do the inverse cosine of the ratio 4 over 15. And if we do that in our calculator, we should then figure out what our angle B happens to be. So let's go to that calculator and see where the inverse function is. If you look right above your cosine, so if I hit second cosine, you'll see that you've got that inverse option, and then we do 4 divided by 15. Remember, I'm in degree mode, so my answer should come up as a degree, and it gives me 74.53 degrees. Make sure you label your angles appropriately. If it's a degree, let us know that it's a degree. So we've figured out how to solve for side lengths and for angle measurements. Okay, another scenario. This time I'm giving you one of your ratios. I'm giving you the cosine ratio, and you are going to find the 5 other ratios, the sine, the tangent, and then the reciprocals. Again, I always try to draw a picture with trig, draw that right triangle. Now, in this problem, I didn't really tell you where theta was. It's not going to be your right angle, but it could be either of the others. So you label it where you want. I'm going to put it down in the bottom corner. What you have to be very careful about is where you put the 7 and the 10 in relation to where you put your theta. So cosine, I remember, is adjacent over hypotenuse. Hypotenuse is easy to label because it's opposite the 90-degree angle in your triangle. Now the adjacent side, we're talking adjacent to your angle. So since I put my angle down here at the bottom, my adjacent side would be this bottom side length. If I would have put my theta up at the top, then the other side length would have been my adjacent side. So you just have to be careful based on where your angle is. Now, because I'm going to find all the trig ratios, I do need to know the other side length. basically the opposite side length of our theta. So I'm going to use that Pythagorean theorem to find out this value. So 10 squared is my c squared, and that's equal to 7 squared plus, and I'm just going to call it my a squared. You can call it x if you want. So we have 100 equals 49 plus a squared. I'm going to subtract that 49 and get a 51 is equal to a squared. Therefore, my a must equal the square root of 51. We will leave exact answers in these problems, so I'm looking for exact radicals. Simplify. So if there's a perfect square in 51, bring the perfect square out, leave it as an exact radical. Those are just some kind of rules of thumb to go by. So now we can find all of our trig functions. So to start with, I'm going to find sine of theta, which says to take the opposite side, which was radical 51, over the hypotenuse, which is 10. We already know cosine, so we can find tangent next, which is the opposite, radical 51, over the adjacent, which was 7. We now need to find all of our reciprocal functions. So remember that cosecant, and I know you're still getting used to those, so you might have to look back at your earlier notes. Cosecant is the reciprocal of sine. So that would give us 10 over radical 51. We might start talking about rationalizing in this unit, where we don't want to see a radical in our denominator. So what we can do here is multiply top and bottom by radical 51. And what that gives me is 10 radical 51 on top. Sorry, I know this is really tiny and scrunched here. And then the bottom, the radical 51s, the radical cancels, and you would just leave a 51. So that would be a rationalized way to write this fraction. Secant, remember, is the reciprocal of cosine. Cosine we knew was 7/10, so 10 over 7. Cotangent of theta is the reciprocal of tangent, so 7 over radical 51. And if I rationalize that and multiply top and bottom by the radical 51, I get 7 radical 51 on top and a plain old 51 on the bottom. And so that would be finding all the trig ratios once you've been given one of them. Lastly, we have some word problems. These word problems are going to make right triangles, and then we can use the given information to find what we are solving for. So in number 6, we have a UFO flying at an altitude of 45,000 feet. So that UFO, that's up in the sky. So we'll call that our UFO. It's headed toward the Hilliard Bradley Football Stadium. We'll say that you are standing at the 50-yard line. So let's say here's our 50-yard line. And so here's you standing. And you are looking up at the UFO. So if this is you, you're looking up at that UFO with an angle of 10 degrees. And we're going to talk about this angle of elevation here in just a second. So angle of elevation from your eyes looking up is 10 degrees. So you can see this picture over here. I've labeled kind of the same idea. We have a person down here, and if you're following their eyesight looking up to some object or person at the top, the angle of elevation is parallel with the ground. And depending on what we're talking about, sometimes it might actually be the ground, but since this is looking up from our eyes, we're talking, just this parallel line to the ground here. There's your angle of elevation. Now, we will also talk about angles of depressions. Angle of depression would mean you're on the top, so now you're this person, but you're looking down. So imagine that parallel line to the ground. It was your eyesight, and then you're looking down, that angle of depression is out here. If you remember some rules of geometry, you might realize that these two parallel lines being cut by this transversal, the angle of depression and elevation are alternate interior angles, and they are the same thing. So these angles are actually always equal. So that might help as we're moving forward. All right, so back to our problem. We want to figure out how far the UFO is from you. So how far would that UFO be? And a couple things we want to also think about here. Let's see. So we've got the height of the UFO above the ground. So you can be kind of particular here. The ground technically is not this line that we drew. Remember, that was the parallel with the ground from your eyesight. So this entire distance is 45,000. And I told you that we're assuming that this person is about 5 feet 6 inches, which is about 5.5 feet. So I know this is just a little bit estimated here, but we're going to say that's 5.5 feet. So really, in our right triangle, this is 45,000 minus the 5.5. So 44994.5. So we're just being kind of technical here. Now, to find this distance that we are from the UFO, we are going to, and again, some people might have thought about finding this hypotenuse distance. I did say just measured along the ground. So just wanted to point that out. That's why I'm put X where I did. And so we're going to set up an equation here using the 10 degrees and then the two sides we know. The hypotenuse isn't being used. So the only trig function that doesn't need the hypotenuse is the tangent. So tangent of 10 degrees is equal to the opposite side over the adjacent side. And so now as we solve this is when we want to multiply the x to the other side, and then we're going to divide by that tangent to get x alone. So 44994.5 all over the tangent of 10. And I just did this on my calculator off to the side. I didn't go into the calculator on the calculator here, but I'll write down what I got. I got 255,176.5. And we are in feet for this problem. So the UFO is still pretty far away. And there's our setup with a word problem. So I want you guys to try the next two problems with a picture and then labeling the pieces and parts you know. Try to come up with your own equation now that you've seen a couple done. The key for this will open up after you have submitted this for the day, and you can at least see then if you got number 7 and 8 right. And then tomorrow we will be doing a homework assignment where you guys will be doing most of these types of problems on your own.